Great North students, this is Mr. Hultgren. I'm going to talk to you about thermodynamics, and we're going to be looking at multi-step problems today. So what you need to have with you for sure is a calculator and your notes so you can write these steps down. I'm going to put these notes up here, and here's the steps that you can, once I get them up here, pause them and then copy them down. The first thing you're going to do is determine what sections of the graph the problem covers. We're covering multiple steps of the graph that you saw in last night's notes. List the formulas that you're going to be needing for each section. List the known unknown variables, so just like you do in all of our other word problems, keep track of everything. Calculate each section's energy separately. That's very important. You got to do each section individually. We'll do a sample so you can see. Make sure you're choosing the correct constants, and then calculate the change in temperature. You're doing it just for the section of the graph that you're on, not for the whole thing. Again, we'll see in the example here. And lastly, when you're all done with doing each section, we've got to add those up. So make sure you pause the video now, write these steps down. Okay, now that we've done that, let's go ahead and look at a sample problem. Now this problem says you've got 33 grams of ice at 0 degrees Celsius and has heat added until it is a vapor at 150 degrees Celsius. Calculate the total energy expended. Okay? So when you're doing this problem, again, we got to look at what the steps are. A good idea is to draw, or on your paper somewhere, kind of do a little sketch of our graph so you can kind of keep track of where you are on this graph. So there's your level or step 1. There's 2, which is when we're either freezing or thawing or melting. And then there's step 3 where we're a liquid. There's number 4 where we're either boiling or condensing, and then lastly step 5 when you're at a gas. Okay? All right, so the first thing we got to look at this problem and determine where are we on this graph. So look up at the problem here, and it says we're at ice at 0 degrees. So we've got to go up to your graph here, and we're dealing with water, so there's 0 degrees. And here's the key on this. It says that it's ice. Ice is solid. Therefore, we know that it's going to be at the section 1 right here where it's ice, but it's at 0 degrees, so it's going to be right at the tail end, right there. Okay, so that's where we're going to start. And then we have heat added until it's a vapor at 150 degrees. All right, so 150 degrees, look at that. So it's a vapor. A vapor is another word for gas, so I know it's going to be up here in level 5, or step 5, and it's 150 degrees. So there's 100, so I'm going to end up, up here somewhere. So you can just put a little dot on your graph just so you can kind of keep track of where you are. Now here's the deal. When you do these problems, it's a multi-step. I have to go from down here, and I have to go through step 2, through step 3, through step 4, all the way up to step 5. Okay, so that means that I'm going to be covering all of these steps on this problem. Okay, so step 2, 3, 4, and 5. All right, the next step, step 2, is to list the formulas needed for each section. Okay, so there they are. They're, as we saw in the notes the other day, MHF, and there's your MC delta T, and then MHV, and then MC delta T. So list those out. Okay, the third step is to list out the known and unknown variables, and then the fourth step is to do your calculations. We have to do each section separately. Okay, so let's play along here. All right, so this first one, we're going to tackle section 2. Well, we're trying to identify what Q is. M is the mass, and then HF is heat of fusion. So where did I get those numbers from? Again, there's 33.3, that's the mass, and then look up at the top there on our chart. We give you the heat of fusion. You're not going to be required to memorize that, so that's that 335. Okay, I'm just going to plug that into that formula, and it's algebra class. Pump that out on your calculator, and you end up with 11,155. Okay. All right, what I would do is just put a little squiggly line or a little mark just to keep yourself organized. There's a lot of numbers in these problems, so stay organized. All right, the next thing we're going to do is we're going to tackle this Q equals MC delta T portion. So now we just finished step 1 right here. Now we're going, or step 2, I'm sorry. Now we're going to go on to this step 3 where it's a liquid. Okay. All right, so the mass is the same, 33.3. Okay, but now be careful. See a specific heat. We are a liquid right now. Notice up top here that we have 3 different specific heats. Okay, we have a specific heat as a solid, and as a liquid, and as a gas. You got to make sure you're picking the right one. So in this case, we are a liquid, right? So we want to make sure we're choosing the correct number. So in this case, we're going to use that 4.18. All right, lastly, the next one here is delta T. Again, delta T is only for the section you're currently working on. So you have to be careful. So on this problem, you have to look up here on the graph. I am only going from here to here. So remember, I'm traveling from here and I'm going all the way through this. So I'm going to travel all the way through step 3. So that means that the final temperature is 100 and my initial temperature was 0 because I'm going through the whole section. Okay, so that's going to be a temperature change of 100. Okay, plug that stuff into your calculator, pump that out, and you get 13,919 joules. Okay, same thing, move on to the next step, do a little squiggly line. All right, now we're on section 4, so now we're up top here. All right, let's continue on. So with this one now, again, now I'm at Q equals mHV, okay, because we're vaporizing. So our mass is still 33.3, and you'll notice here HF, it's a different number. Make sure you are using the correct number and the correct variable and constant. Okay, so 2,259 is our heat of vaporization. Plug that into your calculator, pump that out, and you get 75,224.7. Are you guys tired yet? All right, step 5. Finally, we're to our last one. So now I just have to go in this one last little section right up here. Okay, I'm going from that last little section. So that's what we're going to work on. So again, pull up the same thing. It's just going to be plug and chug with our numbers. Okay, the mass has stayed the same, 33.3. Again, be careful. C is the specific heat for the gas section. Okay, so again, don't get goofed up. Make sure you're working with the right specific heat. Okay, in this case, we are dealing with, oops, sorry about that. We are dealing with the gas, so that's going to be 1.67. That's the specific heat we're going to be using. Okay, and then the temperature change, same thing. You are just doing the temperature change for section 5. So on this one, okay, the start of section 5 is at 100 degrees, and we're ending up at 50. That means we have a temperature change just in that little section right up there. We're final temperature is 150, our initial temperature is 100. So we just, for section 5, our temperature change is 50. Okay, now you plug that into your Q equals MC delta T, plug that number into your calculator, and you end up with 2,780. So what we've done here is we've calculated the energy, okay, for each one of these steps. So when it was a solid, down at 0 degrees, as it was melting, as it was heating up as a liquid, as it was heating up as a liquid here, and then as we were vaporizing, and then lastly, when we were a gas and we were heating up. So the last step is going to be, you have to take these 4 numbers and you have to add it all up together to get your total energy that it took. So you add those all up and you end up with 103,081 joules. Okay? All right, so just to kind of check your understanding to see where you are, make sure after watching this video you're able to do these things that we have listed. And what we're going to do for you, I have another practice problem that is going to be in a separate video. So you can watch this video again, go through it. If you still feel like you need to see another example, there's going to be a separate video that goes through another example as well. And again, if you guys have questions, please pause the video, rewind the video, rewatch the video, email or talk to your teacher.